Hello, grade 7. I am teacher Joyce and I am going to discuss on how to convert decimal numbers to fractions. But before that, let's recall on what are the types of decimal numbers. Okay, that's right. So the two types of decimal numbers are terminating and repeating decimals. So let's first discuss terminating decimals to fractions. So a terminating decimal with n digits to the right of the decimal point is equal to the fraction whose numerator is the decimal times 10 raised to n and whose denominator is 10 raised to n. So to simplify or to to further understand this sentence, we have here some guide for you. So if you have a decimal number and you want to convert it to fractions, so the form that you will get is this: decimal times 10 raised to n all over 10 raised to n. So to better understand this equation or the formula that I have here, let's have the steps in converting terminating decimals to fractions. So first step is to find n, where n is the digits to the right of the decimal point. So for example, I have here 1 and 25 hundredths. So my question is, how many n digits are there in the right of the decimal point? That's right. So our n here will be 2 since there are two numbers or digits to the right of the decimal point. Okay, so for the next step, replace the value of n and indicate the given decimal to the formula decimal times 10 raised to n all over 10 raised to n. So if I have here the formula, I want you to replace the value of n and indicate the given decimal number. Okay, so you can answer it on your notebook. So if we will replace the value of n and indicate the given decimal to the formula, we will have this expression: 1.25 times 10 raised to 2 all over 10 raised to 2. So since n is equal to 2, so we will replace n here by 2. Ayan. And our given decimal is 1.25. So we're just going to replace it. So 1.25. So here is the expression. And for the last step, perform the operation and simplify. So we will perform this to find the answer. And since we have here in this expression an exponent, we will first simplify this 10 raised to 2. So we have here an exponent. So exponent tells you how many times the base used as a factor. So if we have here an exponent of 2, meaning that the 10 here is used two times as a factor. So if simplifying 10 raised to 2, we will have 10 times 10 or 100. So we will write this and in this form. Same here with the denominator 10 raised to 2. So it's 100. Now, the next step is we will multiply 1.25 times 100. So what did you get? So that's right. 1.25 times 100 is 125. and then copy the denominator 100. So we have here 125 all over 100. So as you can see here, we have a fractions that both numerator and denominator have a bigger value. So we will now simplify this fraction. So what do you think is the GCF of both of 125 and 100? Okay, that's right. So the GCF of 125 and 100 is 25. So we can write this fraction 125 over 100 into this form by expanding the numerator and denominator so that we can easily reduce the fraction. So the greatest common factor is 25. So we will cancel both the 25 in the numerator and the denominator. So what would be the final answer? So that's right. So the final answer will be 5 over 4. So meaning that 1.25, or read as 1 and 25 hundredths, is equal to 5 over 4. Okay. So now that you know how to convert terminating decimals to fractions, so let's have an example. We have here 0.4 or 4 tenths. So in step 1, what is n? That's right. So n here will be 1 since we have one digit from the right of the decimal point. Now for this step 2, we will replace n and indicate the given decimal to the formula that we have. Okay, so for this step 2, we will have 0.4 times 10 raised to 1 all over 10 raised to 1. So, okay, so now for the step 3, we will have 0.4 equals this came from the step 2. So now we will simplify the exponent. So 10 raised to 1 equals 10. So the new equation will be 0.4 times 10 all over 10. So now what is 0.4 times 10? That's right. So 0.4 times 10 is 4. And copy the denominator 10. So we have here 4 over 10. So is this the final answer? Okay, so yes, it is not the final answer. So what is the common factor of 4 and 10? Okay, so it's 2. So you will divide 4 by 2 and 10 by 2. So what will you get? Okay, so you will get this answer, 2 over 5. So this is the low fraction in lowest term. So 0.4 is equal to 2 fifths. Okay, I have question. Is 40 hundredths same as 4 tenths? Justify your answer. So following the steps that I have given, you will solve or define or to see, okay? So to see the fraction form of 4 hundredths. 40. So to better understand this problem, I have here, I will show you how. So we know that 40 hundredths discussed by the other teachers, we can write this in fraction form into 40 over 100. And we know that 0.4, so we solved this a while ago, is equal to 4 over 10. So to illustrate this these fraction forms, we will have this one and this one. So as you can see, both are equal. So teacher Teen also discusses that any number that is any zero num any zero digit that is written on a terminating decimal has no significant value. So meaning they are they are just the same. We will proceed in converting repeating decimals to fractions. It says here that a repeating decimal in the form n 0.a sub 1, a sub 2 up to a sub n is equal to the fraction whose numerator is the repeating block and whose denominator is n digits of 9. So to further so understand this statement, we will have the steps in converting repeating decimals to fractions. First step is to multiply the given decimal 10 raised to n, where n is the number of digits in the repeating block. So if I have here an example 0.3, we know that we have a repeating block which is 3. Okay, so now n will be 1. And since the first step is to multiply the given decimal by 10 raised to n, we will have this 0.3 times 10 raised to 1. So simplify the 10 raised to 1 is 0.3 times 10. So what is 0.3 times 10? That's right. So 0.3 times 10 is 3.3, in which we still have this repeating block. Okay, so for the second step, we will subtract the given decimal from the result. So the given decimal is 0.3, and in step 1 we accumulated the answer 3.3. Okay, so what we're gonna do is to subtract the given decimal from the result. So this will be the solution. 3.3 minus 0.3. So what's the answer? So that's right. The answer will be 3. And for the step 3, the given decimal is equal to the fraction and whose numerator is the result in step 2 and whose denominator is 10 raised to n minus 1. The given decimal 0.3 is equal to the fraction, meaning in the fraction form, wherein the numerator is the result from step 2. So our numerator will be 3, and the denominator says here that it will be 10 raised to n minus 1. So we will have this expression, 3 all over 10 raised to 1 minus 1. So first, let's simplify 10 raised to 1. So what will you get? Okay, so that's right. You will get 10. So we will have a new equation here, 3 over 10 minus 1. So simplifying 10 minus 1, we have 3 over 9. So is this the final answer? Okay, so that's right. We will reduce this fraction into lowest term. So what is the GCF, or the common factor of 3 and 9? So 3. You will divide 3 over 3 in this fraction. So you will get 1/3. So that will be the final answer. Yan. So we verify that 0.3 equals 1/3. Same as to our given situation a while ago, that if you have 1/3 kilo, you will have this decimal number. So we satisfy um the steps in either way. So now we that you know how to convert repeating decimals to fractions. Okay, so we will have another example. Okay, so what if we have here 0.18 or 1800s, then a repeating block here. So for the step one, we will identify first the n. So our n will be, okay, very good. It will be 2 because the n signifies the number of digits in the repeating block. And the repeating, as you can see, the vinculum is in 1 and 8. So n will be 2. So the first step is to multiply the given decimal, which is here, by 10 raised to n. So we will have this equation, 0.18 times 10 raised to 2. So 10 raised to 2 is, okay, it's 100. So we will have 0.18 times 100. And now what will you get if you multiply this to? Okay, so you will have 18.18. Okay. So maybe you are wondering why we get 18.18. So if we don't have the vinculum here, 0.18 times 100 will be 18. But since you have a repeating block or a vinculum in 1 and 8, still the process of writing this decimal number continues to 0.181818. So you will still have these digits in the right of the decimal point. Okay, just to clarify. Okay, so for the next step, you will subtract the given decimal from step 1. So in this form, what will you get? 18.18 minus 0.18 will be, that's right, it's 18. So in the step 3, the given decimal is equal to the fraction whose numerator is from the result of the step 2, which is 18, and the denominator is 10 raised to n minus 1. So it will be 10 raised to 2 minus 1. So simplifying 10 raised to 2, we have 100. And 100 minus 1 will be 99. So common factor of 18 and 99 is 9. So we can rewrite this fraction form into its common factors. So 2 times 9 is 18, 9 times 11 is 99. And since we can see that both numerator and denominator have 9, so we will cancel it out, and the final answer will be 2 over 11. So that is the answer. So 0.18 with in terms of repeating block, we have this fraction form, 2 over 11. So how about exploring this part? I want you to compare my next example to the first two examples that I have given. Okay, so what did you notice? As you can see, the first two decimal places here, here in the next example are not part of the repeating block, in which it started from the third digit from the right of the decimal point. It is the same as how we solve the other examples, okay? So, okay, so I will guide you on how to try to solve this one using the steps that I have given a while ago. So, the first step is to multiply the given decimal by 10 raised to n, where n is the number of digits in the repeating block. So, can you identify how many digits in the repeating block are there in this example? Okay, so we have n will be 1, since the repeating block only indicates 3. Okay, so the next one will be yan. We will multiply now we will multiply the given decimal to 10 raised to n. So simplifying this 10 raised to 1, we have 10. So 0.583 times 10. So multiplying this, you will get, that's right, you will get 5.83. Okay, remember this. So in step 2, you will subtract the given decimal to the result that we get in step 1. So 5.83 minus 0.583. So I'll give you time to compute. Okay, so the answer will be 5.25. Okay, so for the step 3, the given decimal is equal to the fraction whose numerator is the result from step 2. And the denominator is in the form 10 raised to n minus 1. So since n is 1, we will replace the value of n by 1. So we will have 10 raised to 1 minus 1. So expression, we will have 5.25 all over 9. So as you can see, we still have decimal here in the numerator. So can you think of a way on how can we get rid of this decimal point in the numerator? Okay, so if you're thinking to multiply the whole fraction, both numerator and denominator by 100 to simplify, to eliminate the decimal point, and you are correct with that. So 5.25 times 100 all over 9 times 100. So simplifying this expression, you will get 525 times 100. 9 times 100, 900. 5.25 times 100, 525. So is this the final answer? Obviously, it's not, because it's too big. It has a larger value on the numerator and denominator. So what we're gonna do is to reduce it. So you will identify the common factor, and since it's too big, I will give you the common factor, which is 75. So eliminating or canceling both 75 in the numerator and the denominator. Okay, so the reduced form will be 7 over 12. So that will be the final answer. So as you can see, we have this problem in the situation that was discussed in the synchronous, wherein we have 7 over 12 kilograms of watermelons, and it was converted to decimal 0.583. So that we verified that 0.583 is equal to 7 over 12.